Hello and good morning again. Before we try to do this lab where we're going to try to determine the internal resistance of a battery, I thought I'd talk a little bit about these resistors. Both the Mechanical Universe video you watched and maybe some experience in life has shown you that there are these things we call resistors. You see them in a circuit board. These are some small ones. The one I was holding is much larger. Actually there was a swap meet kind of flea markety kind of thing, the Stanford Linear Accelerator Center some years ago, and at that swap meet I just saw this pack of resistors and I bought them. I think everything I walked out of that swap meet was in a cardboard box. I paid $10-20 for everything. Anyway, so they have these color stripes on them, and the question is, well, what do those mean? The so-called color code for resistors works in a very simple manner. On the resistor, there's always a band that's closer to the edge and a gap in bands on one edge. And so you read it from the leading edge where there's a band close to the edge. The first band tells you the number that is the first number in the resistor's value. For example, and the way that the color code works is that black is 0, brown is 1, red is 2, etc. There are mnemonic devices people in electronics classes use to learn these. Some of them are not very politically correct, and I'll try to avoid putting that into your mind. One year, because of these kind of politically incorrect sayings, we had a contest, and a kid came up with black bears run over yellow grass, and I can't remember what the rest of it was. The resistor I'm holding is brown, blue, brown, gold. The first band is the first number. So in the case of brown, it is 1. So we have brown, blue, brown, and gold. We'll talk about the fourth band here. The first two bands, band number 1, band number 2, are the first two numbers. Brown is 1, blue is 6. So we have 1, 6, and then times the third band, which is a multiplier. The way the multiplier works is black, which is 0, is the exponent. So 10 to the 0, of course, is 1. Brown is 1, so we have 10 to the 1, which is, of course, 10. It's here for people who don't understand scientific notation as just a straight multiplier. Red being 2, we have 10 to the 2, and that's 100, right? So the multiplier works as an exponential power of 10. So here we have brown, which is 1, so we have 10 to the 1, which of course is the same as 16, times 10, which is 160. So if we were to take the ohm meter, and I have turned the selector to ohms, and I've put the red probe lead in the volt ohm spot. It currently reads overload because the resistance between these two leads is the resistance of air, about 6-7 centimeters of air, which is enormous. So it's on a mega ohm scale, it's more than this meter can read. If I touch the leads, it measures a finite number, in this case 0.7 million ohms, 8.8, that's like 800,000 ohms, but that's because that's the resistance of my body. Resistor that we've established is brown, blue, brown. We should get 160 as our value, and we get 187. So it's not perfect. What's going on? Well, I didn't talk about the gold band. The gold band indicates that it's plus or minus 5%. And of course, 5% of 160, well, 1% of 160 is 16. So 5% of that is 8. And so is this within 8 of 160? Not really, but we're going to live with that tolerance. Let's do one more. These are going to be harder for you to see. These are small. These are more modern. They didn't come at a swap meet at the Stanford Linear Accelerator Center. I bought them at San Mateo Electronics. They are just modern, and they are more closer in their tolerance expectation to the number we would expect. The color is yellow, purple or maroon, and black. So that value, yellow, maroon, black. So it should be 4 yellow, 7 violet, if you wish, purple. Why do I say maroon? Violet. And black is 10 to the 0. So we have 47 should be the value in resistance of this resistor. So let's go ahead and see. It reads 46.6. So that's very close to the tolerance that we expected. And it's a 5% band. It also has a gold band on it. But it's much, much closer. So now let's use these resistors to try to determine internal resistance of these two 1.5 volt D cells, which are in series, so that it's 3 volts should be the EMF of these batteries.